Hey everybody, it's Mr. K here. Hope everyone's doing okay. Today I'm going to real quick go over distance formula, so you'll be able to do tomorrow's activity. For today, just focus on these notes. Distance formula, the purpose of that is to find the distance between 2 points on the x and y coordinate plane. So distance formula is this. Distance equals big square root, because there's a lot of stuff that goes under there. It's x2 minus x1 squared plus y2 minus y1 squared. Now that might seem like a lot, but all you're really doing is subtracting the x's, second x minus the first x, squaring it, subtract the y's, second y minus the first y, square it, add them up, and then just take a big square root of the whole thing. Okay, I'll show you how it's done. It's really easier than it looks. All right, first one. Use the distance formula to find the distance of the line AC. So I've already drawn the line AC. Point A is right here, -2, -2, right there. Point C is 3, 5, which is right over here. So I drew them. You won't always have a picture, but it's good in the beginning to visualize this. Let's use the distance formula first to find out how long that line is. So start with the formula. Distance equals, I'm going to rewrite it for now. For this formula, I do want you to probably write it every time because there's a lot of little places for you to mess up that will take your whole answer and throw it off track. So make sure to write it. And now we just got to figure out, okay, what do I plug in? What are these things? What is x2, x1, y2, and y1? Well, just like we've talked about before, it's these points. So label them first. For the A, that's going to be your x1 and your y1. For C, these numbers are going to be your x2 and your y2. Don't be confused. All that's just a fancy way of saying this is your first x, this is your first y. This is your second x, this is your second y. And, like this little guy says here, it does not matter which one you call x1, y1, and x2, y2. It literally doesn't matter. Finding the distance from one to the other is the same as the reverse distance. So now that you label those, and yes, I do want you to label them just like this every time. Okay? It takes all the guesswork out of the problem. Because now you know to find distance, d equals, the big square root is still, whoa. The big square root is still there. And now you know x2, well, we labeled that. Oh, that's right here, that's 3. Minus the x1, that's all the way over here. That's the -2. Be careful, negatives will stack. That's a minus and a negative. Don't forget to square it. And then it's a plus sign. Now let's do the y's. The y2, I labeled it. It's right there, 5. Minus the y1 is over here, -2. Squared. So it's just a matter of putting everything in its right spot. And now you can do it in your head. You can do the calculator, whatever you need to do. I would do it in chunks because if you type the whole thing in the calculator, you're bound to make a mistake. But some people do that anyway. I'm going to show you kind of in pieces. Here, 3 minus -2 is just 5. This is 5 squared. Plus, over here I have 5 minus -2. That's 7 squared. Cool. How we simplify that? Distance equals 5 squared is 25. Oh, this is still under the square root. 7 squared is 49. Okay. Add those up. You get square root of, what was that, 74? And technically you can leave it like that. Okay? Or you can get the decimal. I'm going to take up my calculator. Let's use decimals. If you're looking for a decimal answer, then just go square root. 74, I think was the number. 8.60. 8.60. Both answers are good. Okay? This is the square root answer. This is the decimal answer. They're both technically correct. We'll learn how to simplify the square root a little bit later. But now, does that make sense for this line? Does this line look like it could be about 8.6? Yeah, I would say it does kind of make sense. If you look at each of these notches being 1, you can't just count when a line is diagonal, but it looks like 8.60 makes sense. Okay. Now this problem also asks us to use Pythagorean theorem to do the exact same thing. You might not remember, but Pythagorean theorem is anytime you have a right triangle, you can say that, use a different color here, purple. You can say a squared plus b squared equals c squared. So you might not remember the Pythagorean theorem name, but this you probably hopefully remember from somewhere. If not, that's okay. Here we are. We're all doing it. They say they want you to draw a point B, 3 comma negative 2. Let's see what that's all about. 3 comma negative 2 is right here. That's point B. The only reason they wanted you to draw that is they're guiding you to create a right triangle. They're showing you exactly where the corner would be, where the right angle would be in this right triangle. So let's see. If you have a right triangle and you know 2 of the sides, and if you look at this picture, we do know 2 of the sides. This side, AB, I can just count the boxes. This is 1, 2, 3, 4, 5. This is 5 units long right here. This box right here, 1, 2, 3, 4, is 7 units long. Cool. So let's use those and let's find this. I'll call this C. It's a question mark. I don't know how. That's what I want to find. I want to find the distance from A to C. So this is another way to find distance. If you have a graph and you can see the points, then oftentimes Pythagorean theorem is actually easier. Okay, so let's do this. A squared, I don't care which one you call the A and B, but the A and the B are the 2 legs of the right triangle. That means the 2 sides that are connected to the right angle. Also, they're the 2 shorter legs. If you can tell by looking at it, the hypotenuse, which we call C, is always the longest side. So I'm just going to call 5 squared, A squared plus B squared is 7 squared equals C squared. I'm just going to solve this for C. Get C by itself. So I know this is 25. This is 49. This is C squared. Add them up. Again, this is 74 equals C squared. Now, do I stop there? Does that look like this line is 74 units long? No way. The C is almost by itself. Question now is, this is a C squared. How do I get rid of a C squared? Well, just like to get rid of addition, you subtract. To get rid of to get rid of squaring, you just square root. But whatever you do to one side, you have to do to the other. Now, guess what? You end up getting C by itself because the square and the square root cancel. And here you just get square root of 74, which, if you get a decimal, is 8.60. Look, you get the exact same answer either way. Okay? So take a look at these 2 methods. They're both important. You need to know both. But if they give you a graph and you can visualize the points, you can draw them, then my advice to you is just use the Pythagorean theorem. In my opinion, it's a little bit quicker, it's a little bit cleaner. But if you take a look, the distance formula really just comes from the Pythagorean theorem. What do we end up doing? We end up finding the distances, 5 and 7, squaring them, and then at the end, square rooting them. Check it out. That's all this is. Find the distances, the 5 and 7 right here. We squared them, and we square rooted them. The distance formula comes from the Pythagorean theorem, so you're doing the same thing. All right, anyway. On this one, we're going to do it. We're going to do it using the distance formula. Pretend like we couldn't even see the graph. Pretend like they didn't give us a coordinate plane. Use the distance formula to find the distance between these 2 points. Now, if I don't have a graph, I'm not going to sit there and make a coordinate plane to graph them. So I could use Pythagorean theorem. I'm just going to jump right to the distance formula, which I've written here. I want you to write that every time. It's the best way to remember it, is to just write it every time you do a problem. Okay? If you're not sure, before you jump into the problem, make sure you check it with the one you wrote in the notes so you know it's correct. All right. So I'm going to let you try this. Okay? I would pause the video, try it on your notes, and then I'm going to reveal the answer. In 3, 2, 1. So hopefully you've paused it, resumed it, and now you're looking to check your work, because here it is. Okay? You'll notice that they've plugged in. I've plugged in the x2 minus the x1. Exactly where it should be right here, 4 minus -3. The y2 minus y1 is 1 minus 1. Okay? And I just went through and calculated. I end up getting square root of 49, which is actually a perfect square. That works out. The answer is 7. Okay? Most of the time, distance, a lot of the time, your answer for distance will be a decimal, and that's okay. Because calculating distances of diagonal lines, usually they're not perfect. Sometimes they are. But this one also wants you to find the distance between these same points by looking at them on the plane. All right, let me graph them. -3, 1 is right here. 4, 1 is right here. Oh, look at those. Let's connect them. That's not even a diagonal line. I can just count the boxes. 1, 2, 3, 4, 5, 6, 7. Well, there you go. The distance between those 2 points is 7, just like the distance formula showed us. So it works using the formula, and if you're able to graph it, it works using the graph. This one was especially easy because the points were exactly horizontal of each other, so they created a perfectly horizontal line. We can just count the boxes for that. Okay? For 3 and 4, we're going to kind of do the same thing here. There's no graph. Look, find the distance. I'm circling that for a good reason. You'll find out with the next video. Between these 2 points, but I don't have a graph. I'm not going to sit there and go -1, 3, because it's got to be perfect. I'm not going to make a graph. Don't do that. Use the distance formula, which is right here. Okay? So I want you to write it down. Pause the video. Try to figure. I haven't even labeled the x1, y1s, x2, y2s. I haven't even labeled where they go. Try to put them in where they go. Do the calculation, and we'll see if we get the right answer. So pause, do it, and I'll reveal the answer in 3, 2, 1. Hopefully you've resumed after trying it on your own. There you go. That's what you should get. Notice again, we got a decimal, but also the square root or radical answer is fine. Okay? In reality, you should probably know both these. Hopefully that checks out. Remember, I'll be available pretty much all day. Shoot me an email if there's any questions. Number 4, same deal. Pause it. Try it now. Reveal in 3, 2, 1. Welcome back. Hopefully you tried it and it went great. Here we go. There you have it. Feel free to pause if you want to check it out. But me, I'm going to move on. Again, any questions, let me know. Distance formula, again, is written here in the next part of the notes. That's just a repeat. Nothing new there. Again, this is just an example from a textbook. Find the distance between these 2 points. Distance. I make sure the problem said distance before I use the distance formula. So here it is. I've written the formula for you again. Please try it. Pause it. Give it a whirl. Welcome back. Hopefully you've done this and you've gotten the answer correct. It's right there. So again, use the distance formula. Make sure you label your X's and Y's. Super important. Okay? I know it seems trivial, but I don't want you to mix the numbers up. Everything gets screwed up when you do. Okay. Then you substitute in the things you labeled. Right? Like the x2 was this. X1 was this. Y2 was that. Y1 was that. Bam. Substituted. Done. Simplify. That's where you do all the math. You subtract. You square. Here's what you get. You even add them up. You get square root of 61. Then you use the calculator if you want a decimal to find that answer right there. Okay? Again, we were able to find the distance between these 2 points without looking at a graph using the distance formula. Great job. This one we're going to talk about next week. Classifying triangles. Some of you guys have already seen these 3 things. Awesome. Little preview. We'll talk about what they mean. We'll talk about how to figure out what they are on the coordinate plane next week. Stay tuned for my next video, which will also be posted today, about midpoint formula. It's just as easy, if not easier, than distance formula. Instead of finding the distance between 2 points, you're trying to find the middle, the very center. The video for that will be forthcoming. Okay? Again, if there's any questions about distance formula, please shoot me an email or message me on Canvas. I'll be around. Tomorrow we'll be doing a practice about distance at midpoint mixed. Okay? Have a great one, guys.